Okay, here we are doing 3 problems from the 2-5 homework. The first one is, I think, problem number 9, where we're going to draw some graph based on pre-existing conditions using limits with infinity. All right? So I'm just going to write those down quickly. I've had my coffee, so I can do that. Okay, so we're going to take each one of these and find out the graph that fits. If f of 0 equals 3, we know that we've got a point at least that is right there. Check that one off. The limit as x gets closer and closer to 0 from the left is 4. So as we're approaching this fixed point 0 from this side, it's approaching 4. Okay, well that's up here. And that just means as we're coming from this side, it's like this. We don't know if it's coming from below or from above, but it's doing something as it approaches that. I'm just going to leave it like that, a little short one, because I don't know which way it curves. I'll fill that in later. Check that one off. The limit as x approaches 0 now from the other side, from the right, is 2. So that's down here. All right, why am I making an open circle? Well, because it has to be a function, and that would fail the vertical line test if these weren't open circles. So that's going to be doing something like that, just coming from the right-hand side. Check that off. The limit as x gets very, very big negative, when x is going that way, it's going to negative infinity. So, I don't know, it's just kind of going down like that towards negative infinity as it gets negative. Check that one off. As x gets closer and closer to negative 4, it goes to negative infinity. Okay, as x gets very close to positive 4, but from the left. 1, 2, 3, 4, from the left. Well, that's an asymptote. That is a vertical asymptote when things tend towards infinity or negative infinity. From the left-hand side, it's going down like that. All right, that's my arrowhead. Check that one off. As it's getting closer and closer to 4 from the right-hand side, it's going to positive infinity, hugging along like that. Check that one off. It gets confusing with the pluses and the minuses and the minus infinities and the positive infinities, but just go slowly. As x gets closer and closer to, gets greater and greater, positive infinity, it goes to 3. So it's going to go then towards a horizontal asymptote like this, because this is out way on the right-hand side. It does something, it can do something funny like that, but it just goes like that and hugs that line. That is y equals 3 line. This is the x equals 4 vertical asymptote. So then we can just make it go up like this, and we can then make it go up like that, and there we have it. Now, I would imagine the book has smoothed those out, but you can be creative. All right, so now we're going to get rid of that and go on to the next problem. This is one where we're actually trying to evaluate a limit. I think this is problem number 24. If we know that f of x, some function that is x plus 2 over radical 9x squared plus 1, and we're taking the limit of this, I forgot to sneak that in, the limit as x approaches infinity, all right? So this is the limit at infinity. As x gets super large positive, what happens to this? Well, I think a lot of these you can just eyeball them and say that as you're getting larger and larger x, this 1 is going to be basically insignificant. You can just drop that off. If we just cover that up, well, you can take the square root of 9, that's 3, take the square root of x squared, that's x, and you have x over 3x, and the x's cancel, and you have 1 over 3. So that's what your intuition, or at least your street smarts, might tell you. Mathematically, what we do is we're going to multiply by 1 in the form of something over itself in such a way that then we can make sense of each of these individual limits. All right? So what that means is I'm going to multiply by 1 over x and then 1 over x again, but to get inside the radical, I'm going to express this like that, as 1 over x squared square rooted, because these will be the same. This is still the number 1. All right? So in doing the math then, as I multiply this in, I'm going to get this equal to x over x, when I distribute that in there, plus 2 over x, all over. Now that I've got both radicals, I can bring this fraction inside. Radical stays there, of course, 9x squared over x squared, and then plus 1 over x squared, okay? And I should be careful about this. This is still the limit as x approaches infinity. I was a little bit sloppy up there. I should have just written this as the book did, I think. Anyway, at this point now, this becomes 1, and I've got the limit as x approaches infinity, and I've got 1 plus, well, as x goes to infinity, this is going to just go to 0, all right? Here, the x squareds do cancel, and I've got the square root of 9 plus, as x goes to infinity, that gets just super large. 1 over a large number is 0. So I have then 1 over radical 9. Oops, maybe that's gone off the board. This equals... All right, well, I'm back. The battery ran out on that last one just as I was about to write the answer, which was 1/3. Okay, there it is. You can see it. 1/3. That was the answer to that final problem. But we're going to move on to one that's a little bit more difficult. You can see that this is problem 25, I think, as an example. We have the limit as x approaches infinity of something that it's not just easy to solve by using sort of street smarts or a simple trick. If we have something like this, it's tempting to want to look at each part like we did in the last one and say, well, if x is going to infinity, this becomes less important because infinity squared is much bigger than x. You might be tempted to say that it's just the square root of that, which would be 3x. Well, 3x minus 3x is 0, so where does that leave you? Because maybe it's 0, but maybe this little bit makes it go to infinity. It's hard to tell. So we're going to multiply by 1 in the form of the conjugate of this in order to try to get a ratio, because we're good at solving these things when they're in fractions, because we can look at which wins, the top or the bottom, which gets big or which gets small. The conjugate of this is the radical and then plus 3x, and then the radical and plus 3x in order to keep this 1. The radical is the same piece as right there. So when I multiply this by that 1, I'm going to get the limit as x approaches infinity. Now, when I FOIL this, the radicals multiply and I get 9x squared. And then the rainbow bits, when they multiply, this bit and that bit, of course they cancel out. That's the whole purpose of the conjugate trick. And then finally, 3x times positive 3x, negative times positive gives you minus, oh sorry, inside the radical is 9x squared plus x, and then minus 9x squared. This is just from foiling this whole binomial with this whole binomial right there. When I multiply the denominator, this is over 1. I just get radical 9x squared minus plus x, and then plus 3x. So that's my new fraction that I get when I multiply by that conjugate. Okay, what happens here? Well, these guys cancel, and I end up with just a positive x. Okay, now I'm not going to do anything down here. There's nothing that I can do, but what I can is multiply again by 1, this time in the form of 1 over x and 1 over x, except that this is a radical. So our trick is to square this and then square root it, and it does not change, but it's written as a radical. Now, how do I know to do this? Well, this is just like one of the techniques we've learned. I'm showing it to you now. There are 2 or 3 examples in the book where they're doing it. So it's a way of sort of simplifying the fractions so that we can use our rules of limits to solve it. When I multiply x times 1 over x, I get 1. I've still got the limit as x approaches infinity. When I multiply a radical times a radical, I can go inside the radical and multiply 1 over x squared with the radical still on the outside, and I'll get 9x squared times the 1 over x squared. I'll rewrite this as 1 squared, which is 1 over x squared. And I get 9 squared over x squared plus x over x squared. And then this times the radical is plus 3x over x squared. Okay? Now I'm getting somewhere because the x squareds cancel, And I've got the limit as x approaches infinity of 1 over the square root. When the x squared is canceled, I get 9. When this x cancels with that x, I get 1 over x. But that then will go to 0. 1 over x will go to 0. And then outside, oops, I bet that's getting chopped off. I'll try to squish it in here. Plus, and then it's 3x cancels the x's with that x squared, and I get 3 over x. Well, when x goes to infinity, that also goes to 0. No, because this is still under the radical. So when I multiply this right here, I keep the radical. When I'm multiplying it with something that doesn't have a radical, remember it's 1 over x. So I nearly made a mistake, but I knew that I was not going to have that drop away, so I get 3x over x. Again, because the square root of 1 over x squared is just 1 over x. When I multiply that times 3x, I get 3x over x. The x's cancel, and I get plus 3. So then this equals the limit as x approaches infinity of 1 over radical 9 plus 3. And that just gives me 1 over 3 plus 3, which equals 1 over 6. Okay? 1 over 6.